everything you think you know about the darkness between galaxies is wrong. For decades, we assumed that the vast stretches of space separating galaxies were essentially empty, black, cold, nothing. That assumption shaped every cosmological model we built, every simulation we ran, every theory we had about how the universe evolved. And last week, astronomers proved that assumption was completely false. The space between galaxies isn't empty, it's glowing. It has always been glowing. We just didn't have the tools to see it. Until now. To understand what was just discovered, you need to go back about 10 billion years. The universe is young, roughly a third of its current age, and it's doing something extraordinary. Astronomers call this era cosmic noon. It's the most productive period in the history of the universe, galaxies forming at a furious rate, stars igniting by the billions, the entire cosmic structure we see today being assembled piece by piece from gas and gravity. This is the universe at its most alive. But when we look back at that period, we've only ever been able to see the brightest parts. The galaxies themselves, massive, luminous, unmistakable. Everything in between, invisible, or so we thought. A team of astronomers working with the Hobby-Eberly Telescope in Texas just changed that. Their project, called HET-DEX, the Hobby-Eberly Telescope Dark Energy Experiment, has spent years collecting data, not just from galaxies, but from everything. Every photon that entered the telescope. Over 600 million spectra across a patch of sky covering the equivalent of more than 2,000 full moons. And when they finally analyzed what they'd collected, they found it. A vast network of glowing hydrogen gas threading through the space between galaxies, stretching across billions of light years, filling what we thought was empty space with light. Not a faint shimmer, a sea of it. Emitted during the most intense star-forming period the universe has ever experienced, this light has been traveling toward us for 10 billion years, and we missed it entirely until now. But here's where it gets really interesting. The reason we missed it isn't because we weren't looking. We've pointed our best telescopes at the early universe for decades. Hubble, Spitzer, Webb, all of them. The reason we missed it is because of how we were looking. Think about how city surveys work from the air. If you only photograph the downtown skyline, you understand where the population centers are. But you miss the suburbs, the small towns, the villages. You miss everyone who doesn't live in a skyscraper. That's exactly what astronomical surveys have been doing for decades, mapping the brightest galaxies and assuming the picture was complete. HET-DEX used a different approach. Instead of studying individual objects one by one, they used a technique called line intensity mapping, essentially taking a blurrier but far more complete picture of everything in a region of sky simultaneously. It's the difference between photographing a city at night from orbit versus counting every lit window. The new technique captures the aggregate glow, not just the brightest sources, and when they applied it to 10 billion years of cosmic history, the entire hidden network of intergalactic gas came into view. Here's the scale of what they found. The team processed roughly half a petabyte of raw data, that's 500 terabytes, using supercomputers in Texas to build their map. The light they detected comes from hydrogen atoms energized by nearby young stars, emitting a specific wavelength called Lyman alpha. This isn't new light, it's ancient light that has been crossing the universe for longer than our solar system has existed. The sun hadn't formed yet when these hydrogen atoms first started glowing. But there's something most people aren't talking about. Only 5% of HET-DEX's collected data has been analyzed so far. Let that sink in. This discovery, the largest, most accurate 3D map of the early universe ever constructed, was built from 5% of the available data. The remaining 95% is sitting in servers in Texas, unprocessed, waiting. Eiichiro Komatsu, scientific director at the Max Planck Institute for Astrophysics and a co-author on the paper, put it this way: "We have computer simulations of this period, but those are just simulations, not the real universe. Now we have a foundation which can let us know if some of the astrophysics underpinning those simulations is correct." In other words, everything we thought we understood about how the early universe worked was based on models. Now we have the actual data, and it's showing us that the models were missing most of the picture. And this is where it gets personal. You were born in a universe that was, in a very real sense, hiding from us. The cosmic structure that built your galaxy, that forged the atoms in your body, that laid the groundwork for every star and planet and living thing that has ever existed, that structure was assembled inside this glowing network of intergalactic gas. Gas we couldn't see, processes we couldn't trace. For all of modern astronomy's power, we were looking at the universe the way you'd look at an ocean by only studying the islands. What the HET-DEX team has opened is a window, not to one region of the sky, not to one galaxy or one cluster, but to the hidden architecture of the entire early universe, the filaments and webs of gas that connected galaxies, fed star formation, and shaped the cosmic structure we inhabit today. The implications are significant. Astronomers now plan to cross-reference this new map with existing surveys of carbon monoxide and other molecular signatures, building a multi-layered picture of cosmic noon that no previous generation of scientists could have imagined. And as new instruments come online, more sensitive telescopes, more powerful computing, that remaining 95% of data will gradually be unlocked. The map we have today is already the most detailed view of the early universe ever created, and it represents 5% of what's coming. The universe spent 10 billion years hiding this light. The fact that we finally found it with a telescope in the Texas Hill Country, processing half a petabyte of data on supercomputers, using a technique that resembles a smudged window rather than a perfect lens, says something remarkable about how science actually works. Not through single dramatic breakthroughs, but through patience, through asking a different question, through being willing to look at the blurry version of the sky instead of waiting for the perfect photograph that never comes. The early universe didn't reveal itself by getting brighter. It revealed itself because we finally learned to look at the dark. Here's the question I want to leave you with. If our picture of the early universe was this incomplete for this long, what else are we still missing? What other light is traveling toward us right now, carrying information about structures we haven't learned to see? Let me know your thoughts in the comments. We've been reading the universe like a book with 95% of the pages missing. We just found the very first new chapter, and the story is far stranger and far more beautiful than anyone expected.